And this is the IOCCC best one-liner. Classic.
Yes. The best one-liner is a long tradition in the C contest. We've had this awarded many times over the years. And the best one-liner is a one-line piece of code. And Lee and I have sort of said that 140 characters is kind of the limit for, we'd like to see less than one-liner. So you only have maybe about 100 characters to do something amazing. So your code has to be dense, and you need more than just one trick. It's not just a single trick there. You don't have a lot of luxury for tables and other things. So you have to be very judicious in your characters to do something impressive in one line. It's one of the most difficult categories to try to compete in. And the person who did it very successfully. So who won the tradition of best one-liner?
And the IOCCC best one-liner is by Stedolan from Ireland.
Well done, Stephen. Your first win. I was looking at this also the first time we've had a winning category from the Republic of Ireland. We asked you, what does the following single line of C code do? Let's talk about going forward and seeing how you compile this one-liner. Gives you a little bit of a chance to see what this code might do. Okay, so here is how you compile this person's code. And it is, again, congratulations, Stephen, for your first winning entry. It also is the first entry from we've received from the Republic of Ireland. And as you can see from the code, it does include a scenario. I believe we now have, if I switch over to here, and there I got the control back. So here's the one line, again, as we saw it, the source. And people sort of honed in on this part to say that's an image 80 by 80, which you're correct. But let's look at this. Let's dive into this piece of code a little bit more. So when you run the code, it reads in 10 hex characters on start input and produces an image. And this is an example of some of the images. In particular, look at this one here. This one here is when you take the source code and you MD5 hash it, and you feed the MD5 hash as input to the source code, it prints out C, which is an interesting thing, and how it actually manages to do that, how the MD5 hash of the source produces an image that says C. That's another bit of magic that's going on here that we quite like. So when you Clang format it, what you'll see is you got this for loop with this putchar expression. And so you've got an initializer, the terminator, and the iterator, and it's printing out these characters. Okay, so you say, well, what is it? Well, let's take, here's the original code as Clang did, and let's format it a bit more. Let's undo the for loop so that we have essentially these preconditions of printing out a P1 8080, which is saying we're printing out this particular black and white image that is 80 by 80. And then it scans 10 hex characters on input, and it outputs this. That output is of the image, but it's not clear that it's outputting in the characters for an image. So let's go and dive a little bit further into the set. When you try to compile this, you'll get these warnings about operator present. That's not a valid thing, but it's saying, hey, there's some operator present you want to be aware of. So we can go and actually, and you'll see here's the original image, and we replace it with something so that you don't have the warnings. And but again, it still seems to be pretty obscure what's going on. So we'll do another iteration. We'll take that expression that was here and break it into several sub-expressions. In particular, this computing this thing we call now W. If W is 0, V gets to be 1, otherwise it's 0. And V is then XORed with 49. The other side of the coin of this if, because this is if around whether X is less than 5 or more, and the other side of that if is a new line. So it's printing characters, or depending on if X is less than 5, prints a new line. And here's the iterator. So let's break this down a little bit more. And we see that we can turn it back into a for loop, because that iterator, or the terminator of the for loop, when that becomes 0, so the for loop ends, is when Z becomes 6480. And Z is merely being incremented through the for loop. We put it up here now, and this X is being computed. We also can see now what's happening is that the W expression is taking this complicated thing here, and depending on whether W is 0, 1, will put out a ASCII 0 or ASCII 1, dealing with either foreground or background image, which is going to be a black or a white pixel with the new lines on this side. So doing a little bit more, if you take a look at the output, you'll see the P1 saying the type of image. You'll see the 80 by 80 showing you that it's 80 rows, 80 columns. And then we see these blocks that occur. Those are those pixels you saw, the black or white pixels, showing you what is done based upon the input. Now, if you go further and look at the code, you say, okay, we now know it's a PBM because of the P1. We know we have this block size of 8. We know that we have these 80 by 80 things, so we can start to put in some constants. So these are less magic numbers and more printing out the rows and columns, going through all the rows, all the line lengths, all the characters. We know now that this X less than 5 has to do with this half line block value. And W now can be further. So again, W being a 0, 1 or new line, depending on whether you're in the below the half blocks or not. If you go further and look at the coordinate system he's developed, there's sort of these 8 by 8 blocks that you see here. You can think of a y-axis down the side where the things here, you got less than 0 or more than 0, so that when it goes off to when the block number goes to 5, then it'll print a new line. So that's how he's able to stop it at 80 characters, because the block number advances. The block number is an 8 by 8. When it gets to 5, it's time for new line and reset. So if we look farther into his code, we now have the notion of what's going on with regards to computing the block number, how it actually decides based upon computing Y and W as to whether or not it is going to print out a foreground or background character or do a new line.
The chat is saying somewhere out there, Landon, some AI training scraper is burning.
Yes. And if you go a little bit farther, what you'll see is this. So we've actually turned around and said, okay, we know it's a block number, so we can compute the block number here and use these expressions for W, right? Either if you're on the left side or right side of that axis, you'll either do the first expression or the second expression. So when you get W, then you know whether W is going to be a 0 pixel or 1 pixel, or if you're beyond the half block store, because remember the 0 coordinate was in the middle, the 0 axis coordinate, a y axis in the middle. So if it's beyond the edge, then you get a new line. So the main magic, and we'll do a little bit more here, just a little bit more to show you. The main magic is that you either have a left side expression or right side expression to print the black or white pixel, and you have the new line to terminate the line. So we've taken that single line and broken it there. Now we have limited time on this show. It's long enough as it is. So one of the things your job is going to be to figure out is what in the heck is that expression? How does that expression take G, which is read in on input, and turn that into ones or zeros? And moreover, how does the MD5 hash of the source code produce an image that has C on it? That's for you to decide.
Because it's not symmetrical.
You have to see what you can find out. Yes. Yeah. But well done, Stephen. Brilliant one-liner.
Very fun.
Very difficult to do. Very well executed. Well done. Thanks for watching. And before you go, please like and subscribe and check out the social media links in the description below. And if you like, you can support us on Patreon to help us bring you new content so you may enjoy our favorite universe even more.